Okay, hi, I'm Richard, as you know. So today I'm going to be proving to you that Kivy is the awesomeness. Okay, now that's a very bold claim, very subjective, and as a scientist and lover of reason, I'd never want you to believe me, but I'm going to present you with a bunch of videos and evidence that will lead you to the inescapable and inevitable conclusion that this is indeed the case. Kivy is the awesomeness. Okay, so what is Kivy? Let's just quickly go over the basics. Kivy is a platform-agnostic, full-stack Python framework for the rapid development of engaging GUI applications. Now, I prefer using platform-agnostic over cross-platform, as I've used a lot of other cross-platform toolkits before. You inevitably have to start caring about that platform. The colors are a bit different. The font sizes are a bit different. When you deploy to another OS, you're using a different toolkit underneath. They try to look native and behave, and that inevitably leads to bugs and effort. Kivy does not behave this way at all. We've run on iOS, Android, Linux, Windows. It behaves identically. The only if we have is on iOS to detect a read-only part of the file system, but that's it. And that's even solved in a later Kivy version, which has a user dir, which also automatically is writable. So yes, it's platform agnostic. There's almost no difference between your platforms apart from your software keyboard. Of course, that's pretty much an inherent thing you can't really avoid. But yeah, I'll touch on that again later. Anyway, it's full stack. It's got a complete set of modules and supporting libraries and tools. It's Python, so it's fast. It supports RAD. It's got we call it a novel user interface toolkit rather than just a GUI toolkit, as it really does develop unique interfaces. There's a lot more you can do with it, and it's a lot more flexible than just a typical GUI toolkit, and it creates something which is quite novel, a different experience. It doesn't feel like the other apps on your phone or the other apps. It feels really unique, and that's very much one of the strengths of it. It's also RAD has got its own language for declaratively defining your GUI. It's also quite nice. You can separate your concern. You've also got your GUI lying in KV, your logic lying in Python. It's multi-touch and a whole lot more, but I'll get into that later. It's hardware accelerated. It's fast. It's self-contained, and it's open source MIT license. So there's also no commercial restrictions. It's all hosted on GitHub, GitHub/Kivy. Yes, go and have a look there. That's where the code is kept. Okay, so why Kivy? That's what Kivy is. What are the compelling reasons? Okay, where to start? It produces fast, fluid, and sexy interfaces. It's modern, it's mature, and we'll shortly, just by looking at some apps, I think you'll get an idea of what it's capable of. It's got great support for hardware. It supports a wide variety of protocols. It easily interfaces with CCT type libraries, being Python-based. It's well-designed and event-driven. There's a lot of, as you explore the architecture, there's a lot of great ideas, a lot of good practices and design patterns are baked into the framework. So it really makes it very pleasant to work with. So we don't have time to go into everything, but we've also, I'll just mention, for example, at core, the Kivy uses a listener pattern. It transforms just normal Python properties into rich objects for dispatching events, which you can subscribe to, and this also leads to very nice design codes because it's decoupled. You can just bind to an event if you want to be notified, and you'll get a notification when it changes. It's all very nicely thought out. It's very flexible, very extensible. For example, they also use the mix-in pattern for your GUI widgets. For example, button would be, for example, your developer presentation, then mix in a button behavior class to give it all the button behavior. So even in your widgets, the way it behaves and the way it's styled is very different, and it allows you very easily to build your own widgets which behave just like the normal Kivy widgets because you've mixed in that behavior class. Okay, so it's great support for hardware interaction, uses recognized design patterns. Yeah, too long didn't read, it's just awesome. Okay, so why me? Well, as you can probably tell, I'm a born-again Kivy evangelist. I develop educational software for CAMI education for a profession, and we have a really large VB6 code base. And when VB6 was extinguished by Microsoft, we really searched for a long, long time for a clear direction. .NET wasn't it, WX widgets wasn't it, GTK, Qt, GWT, Pyjamas, Zul, Free Pascal, Lazarus. We really looked at a lot of options, all with their own compromises and promises. And Kivy was a total game changer for us. It was free, it was cross-platform, it was exciting, it was responsive, it was rad, it was flexible, it pretty much ticked every box we could have asked for. And it gave us mobiles and desktop in one code base. So yeah, I fell in love with Kivy and started contributing back. Then in 2013, I was invited to join the team, at which point I fell to my knees and cries of, I'm not worthy. So Yeah, so I spent then a lot of my time helping out on the forums as well as contributing, through which I was offered contract work for a company in the Netherlands called Brain Trainer Plus. They develop games and puzzles for treating the aged and mentally ill. They're very simple games, but research has shown that they really help increase the quality of life of the elderly, as well as stimulate those with mental illness and help them treat a lot of mentally ill patients, suffering from things such as dementia. So they wanted help porting their app to Kivy. And then, it's quite interesting. And then I asked us, well, what are your reasons for switching to Kivy? And this was his quote. At the time, Pygame was good enough. But as hardware evolved, screen resolutions increased, and touchscreens got multi-touch support, we really needed a framework that could do more and could handle these things better. The only framework that can do all of these things and more is Kivy. Kivy handles all our requirements and gives us the ability to port our code almost unchanged to mobile devices. What's more, the Brain Trainer Plus games are released as open source. So yes, sorry, I missed the line there. Frameworks do all these things. The only framework that could do all these things is Kivy. Yeah. So yes. Anyway, so that's Brain Trainer Plus. They release these things and sell them to old age homes. The nice thing about it is that what they develop is released as open source and distributed as educational games to children. So they develop and sell this professional package to the old age homes, but the actual code we write is open and helps educate children. So it's really one of those nice feel-good projects. Okay, but enough of the feel-good stuff. Let's get to some prettiness. Okay, hi, I'm Richard, as you know. So today I'm going to be proving to you that Kivy is the awesomeness. Okay, now that's a very bold claim, very subjective, and as a scientist and lover of reason, I'd never want you to believe me, but I'm going to present you with a bunch of videos and evidence that will lead you to the inescapable and inevitable conclusion that this is indeed the case. Kivy is the awesomeness. Okay, so what is Kivy? Let's just quickly go over the basics. Kivy is a platform-agnostic, full-stack Python framework for the rapid development of engaging GUI applications. Now, I prefer using platform-agnostic over cross-platform, as I've used a lot of other cross-platform toolkits before. You inevitably have to start caring about that platform. The colors are a bit different. The font sizes are a bit different. When you deploy to another OS, you're using a different toolkit underneath. They try to look native and behave, and that inevitably leads to bugs and effort. Kivy does not behave this way at all. We've run on iOS, Android, Linux, Windows. It behaves identically. The only if we have is on iOS to detect a read-only part of the file system, but that's it. And that's even solved in a later Kivy version, which has a user dir, which also automatically is writable. So yes, it's platform agnostic. There's almost no difference between your platforms apart from your software keyboard. Of course, that's pretty much an inherent thing you can't really avoid. But yeah, I'll touch on that again later. Anyway, it's full stack. It's got a complete set of modules and supporting libraries and tools. It's Python, so it's fast. It supports RAD. It's got we call it a novel user interface toolkit rather than just a GUI toolkit, as it really does develop unique interfaces. There's a lot more you can do with it, and it's a lot more flexible than just a typical GUI toolkit, and it creates something which is quite novel, a different experience. It doesn't feel like the other apps on your phone or the other apps. It feels really unique, and that's very much one of the strengths of it. It's also RAD. It's got its own language for declaratively defining your GUI. It's also quite nice. You can separate your concern. You've also got your GUI lying in KV, your logic lying in Python. It's multi-touch and a whole lot more, but I'll get into that later. It's hardware accelerated. It's fast. It's self-contained, and it's open source MIT license. So there's also no commercial restrictions. It's all hosted on GitHub, GitHub/Kivy. Yes, go and have a look there. That's where the code is kept. Okay, so why Kivy? That's what Kivy is. What are the compelling reasons? Okay, where to start? It produces fast, fluid, and sexy interfaces. It's modern, it's mature, and we'll shortly, just by looking at some apps, I think you'll get an idea of what it's capable of. It's got great support for hardware. It supports a wide variety of protocols. It easily interfaces with CCT type libraries, being Python-based. It's well designed and event-driven. There's a lot of, as you explore the architecture, there's a lot of great ideas, a lot of good practices and design patterns are baked into the framework. So it really makes it very pleasant to work with. So we don't have time to go into everything, but we've also, I'll just mention, for example, at core, the Kivy uses a listener pattern. It transforms just normal Python properties into rich objects for dispatching events, which you can subscribe to, and this also leads to very nice design codes because it's decoupled. You can just bind to an event if you want to be notified, and you'll get a notification when it changes. It's all very nicely thought out. It's very flexible, very extensible. For example, they also use the mix-in pattern for your GUI widgets. For example, you don't, button would be, for example, your developer presentation, then mix in a button behavior class to give it all the button behavior. So even in your widgets, the way it behaves and the way it's styled is very different, and it allows you very easily to build your own widgets which behave just like the normal Kivy widgets because you've mixed in that behavior class. Okay, so it's great support for hardware interaction. Users recognize design patterns. Yeah, too long didn't read. It's just awesome. Okay, so why me? Well, as you can probably tell, I'm a born-again Kivy evangelist. I develop educational software for CAMI education for a profession, and we have a really large VB6 code base. And when VB6 was extinguished by Microsoft, we really searched for a long, long time for a clear direction. .NET wasn't it, WX widgets wasn't it, GTK, Qt, GWT, Pyjamas, Zul, Free Pascal, Lazarus. We really looked at a lot of options, all with their own compromises and promises. And Kivy was a total game changer for us. It was free, it was cross-platform, it was exciting, it was responsive, it was rad, it was flexible, it pretty much ticked every box we could have asked for. And it gave us mobiles and desktop in one code base. So yeah, I fell in love with Kivy and started contributing back. Then in 2013, I was invited to join the team, at which point I fell to my knees and cried with cries of, "I'm not worthy." So I spent then a lot of my time helping out on the forums as well as contributing, through which I was offered contract work for a company in the Netherlands called Brain Trainer Plus. They develop games and puzzles for treating the aged and mentally ill. They're very simple games, but research has shown that they really help increase the quality of life of the elderly, as well as stimulate those with mental illness and help them treat a lot of mentally ill patients suffering from things such as dementia. So they wanted help porting their app to Kivy. And then, it's quite interesting. And then I asked us, well, what are your reasons for switching to Kivy? And this was his quote. At the time, Pygame was good enough. But as hardware evolved, screen resolutions increased and touchscreens got multi-touch support, we really needed a framework that could do more and could handle these things better. The only framework that can do all of these things and more is Kivy. Kivy handles all our requirements and gives us the ability to port our code almost unchanged to mobile devices. What's more, the Brain Trainer Plus games are released as open source. So yes, sorry, I missed the line there. Frameworks do all these things. The only framework that do all these things is Kivy. Yeah. So yes. Anyway, so that's Brain Trainer Plus. They release these things and sell them to old age homes. The nice thing about it is that what they develop is released as open source and distributed as educational games to children. So they develop and sell this professional package to the old age homes, but the actual code we write is open and helps educate children. So it's really one of those nice feel-good projects. Okay, but enough of the feel-good stuff. Let's get to some prettiness. Okay, this is one of the first Kivy projects. It's a project called Table Atom Mineral Touch, and it was installed in the Museum of Natural History in Lille, France in 2011. So it's part PyMT and part Kivy, but it explains where Kivy comes from. So in the beginning there was PyMT, and that was pretty multi-touch, and it was pretty, and it was Pythonic, but it was also suboptimal. The developers saw there were better ways to do things, but it would mean breaking backwards compatibility. So what they did was they introduced that, and the project was reborn as Kivy. All the experience and learning gained from PyMT was rolled into Kivy as the next generation framework. So in addition, the hardware requirements were also fixed at OpenGL ES2, so mobile devices could be easily accommodated. So it also helps to explain why Kivy is both fresh and exciting, yet mature and stable. It inherits a rich legacy of multi-touch learning and large-scale application development, yet has mobile and lightweight processes fairly and squarely fixed in its aim. It's really the best of both worlds. I mean, as you can see what's a novel user interface here. There's no touch involved. They're using disks to twist through and basically rotate through the properties of the mineral. By moving the disks together, they can associate the minerals. Yes, so another takeaway is that Kivy is more than just touch. You'll see we use various forms of input later. And it's also why it's called a novel user interface. It's very different, and you can design the interface pretty much any way you want to. It's just a touchscreen that receives input events, which have a rich stack of properties, and you can use however you want them. But yes, and Kivy, in order to isolate that, Kivy uses an input provider abstraction. So that kind of isolates your dependencies on any input devices. And if you want to, for example, use a different input device for Kivy, you can just wrap it in an input provider, and it'll pretty much work effortlessly with all your widgets and all your other events around that. So what happens is your input provider just produces a motion event class that has your basic XY, but it also contains a profile about the touch device. So you can also get information about the device if you want to. Otherwise, you can just look at the X and Y properties. So this is another project. Also, just to show you the scale of kind of some of the exhibition-sized displays that Kivy runs on. So I desperately wanted to get hold of the hardware specs for this. Unfortunately, I didn't. But this was a project presented in Geneva, Switzerland by Christina Au as a student of the Master of Arts and Design, also in 2011. And the artwork intends to explore and challenge the idea of exhibition spaces being white cubes and introducing digital volatile spaces that are explorable. So this is basically a huge touchscreen with a blanket, your fabric put on top, and basically the observer interacts with the exhibition and discovers parts as they interact with it. It's a really massive display, and it's, as I said, I wish I knew the hardware specs. It's a serious screen resolution. One of the things to keep in mind here is that these projects are relatively old hat for Kivy. This is where Kivy comes from, so it's very used to doing large-scale exhibitions, and it's got as I said, a large history of multi-touch experience. It comes out in a lot of ways. I'd love to go into the details of widget inputs and how that works and how it's very different from other toolkits, but it's also a brilliant learning. And it's really doing touch much better. But we don't really have the time to go into that now. So we'll move on to the next project when this is done. Sorry? Oh, that was just part of the video of the thing. I'm not sure what they used to do. Yeah. Anyway, so this is Particle Panda by Chaos Buffalo Labs. So Particle Panda is a particle effects simulator for particle systems. It allows you to develop custom animation and games for artistic expression or just because you're bored. The animations they're created with Particle Panda, and they can be exported to PEX files, which are basically video files compatible with Starling, with Flash, Coco 2D, and with Kivy engines. So using the interactive GUI, particle effects can be changed and edited in real time. You'll see here it's quite also a good showcase of some of the standard Kivy widgets, sliders, tabs, text inputs, buttons. It gives you a nice idea of the typical look and feel if you use the standard Kivy toolkit. I'll show you some alternatives later. But also notice, even during the heavy rendering load, the app remains very responsive and interactive. You can touch on that thing and create new sprites, change them. It's a very intuitive and fun way to create particle effects. Of course these can be changed. I'll show you some alternatives later. Incidentally enough, by the same guy who wrote this, but I'll introduce him later as well. The standard look and feel of Kivy widgets, some of you might know, is based on the Moblin mobile spec from the days of MeMo and the MeGo operating system, which died with Nokia. But it's really fully customizable. You'll see, I'll show you our app later, which looks totally different, but it's using the same widget classes underneath. The easiest way is obviously just, for example, buttons have a background down, a background normal. You can simply change those images to PNGs that you want, and you get a totally different look. You can, of course, subclass, do all kinds of things with them. As I said, you can even, for example, if you want to totally redefine a button, you can have a widget, just mix in a button behavior class, and then you'll get everything that a button normally does. This is also running on a standard Android device. And there you can see selecting from PEX files. And as I said, they are exportable and usable in a wide range of platforms. Okay, then this is the next app I'm just going to go over. This is Cammy's new next generation educational platform. So we're using Kivy here. As you can see, it looks totally different because we've just rethemed things, but underneath it's all the same code. There's a few things that I'd like to point out here. The first is, this is probably the first app you'll see which uses screens in Kivy's. the transitions from one to the other. Basically, Kivy is a one-window kind of environment. For mobile, where you only really have one window. And for a lot of simplicity's sake, you're pretty much limited to a window per Kivy app. So you don't have the idea of multiple forms and floating windows. The way you do that kind of thing is with a screen. The nice thing is the screens are pretty. You get transitions very easily. You can change those transitions. You get slide, swap transitions, wipe. You can roll your own if you want to actually go into the OpenGL stuff, but that's, not for me. I just much prefer the high level, thank you. Also get pop-ups, modal pop-ups, but as you can see, it's a very responsive app. We also choose to use to write our own keypad for input, because we found on mobile devices, you don't want to lose half of the screen to a keyboard, especially when you're just trying to type in a number. So we're trying to take a more optimal approach and free as much of the screen space as possible, and then provide a keypad that is basically allows them to input the number at the moment. Here's also a nice showcase of basically how effortless animation is here. Kivy provides a lot of libraries and widgets to help you with that. For example, URL request does an async call, and you get a call back basically when your data events from that gets back from that request. Async image is another widget you have. You just give it a URL. Doesn't block anything. When the widget comes, your picture disappears. So it's got a lot of nice tools and widgets for being able to create effortless sort of and intuitive things. I mean, and you can easily create non-blocking code, which is quite tricky to do in other toolkits I found. But anyway, so there we've also created a hamburger icon. But as you see, the app is very responsive. We've actually got there's only one of our reviews on the App Store which is not a 5-star rating. And it's one of those things, it's a pleasure to demo. I take it to teachers, and they just start smiling. And that's another reason why I love Kivy, because it's really easy to make me feel like a rock star. So let's look at another app that demonstrates Kivy responsive. This is a small project called Flat Kivy. Now, Flat Kivy is a collection of experimental material design widgets for Kivy. They are inspired by the Google's material design initiative and make use of binding to implement what WebDev would call responsive design, where the UI updates and resizes naturally based on screen resolution. As you can see here, you can resize this to almost anything, and it'll still be usable. Some of the text reflows in certain borders, but you get an idea how easy it is to do different screen resolutions. Always remains usable. So these users you can use instead of the standard ones. You see from the pop-ups they also implement that ripple effect, which is also, I think, part of the material guidelines. I could be wrong, but it gives you a clear indication of where you've touched and what you've clicked, and that you can see the device has responded immediately, even if it takes a little while to get something. You can see he has also done a whole bunch of pop-ups to do sort of specialized input. When you're entering a centimeter, it shows you a centimeter and the appropriate decimal. So it's a very nice and fast little app. We can also learn here that Kivy does a great job, not just of games and sort of novel, exotic apps, but even of line of business apps. This is a very utilitarian and functional and practical tool. So it's perfectly usable and very suitable, especially because this is so easy to do. Even for line of business apps, I think there's a very strong case for using Kivy. Another interesting aspect of this project is its author, Jacob Kovach. He is the resident OpenGL guru at Kivy, and he also develops a high-performant gaming engine built on or using Kivy. So to explain that, Kivy widgets are really built for rich interaction and have sort of a lot of bindings around them, and it can become quite suboptimal if you start talking hundreds of sprites on a screen. So Kivent gives you a way to handle many more sprites in a highly optimized way. So you can still have your Kivy widgets, but then you'd use Kivent to introduce just dumb sprites that don't really block anything. And using this approach, he's managed to sort of make Kivent work for over 100,000 sprites. Okay, but I see we've got to move on quickly. So this is Robotics. Here we have a program called Tic Tac Touch by Dominique Beaumont and Livio Conzette. Consists of a multi-touch screen used to control PLC hardware machine via libnodave. So it exposes C interface, as does most pluggable hardware, and it makes it very easy for Kivy to talk to. So being Python, it's almost trivial to make Kivy talk to this kind of hardware. As you can tell, he's just playing tic-tac-toe with the robot. Incredibly pointless, but also incredibly fun. Yeah, and you can see it's quite an interesting face as well. It almost looks like handwriting, hand-drawn. Gives a nice amateur or playful feel to the app. So, yeah. So this leads to the next project I'm going to show you is Liatris. Now, Liatris is an open source project that determines the object's exact position and identity using a touch screen and an RFID tag reader. So the beauty of this solution is really its cost and sophistication. So to elaborate on that, one of the major challenges in robotics is visual analysis. It's a hard problem. Determining what an object is, how it's positioned, and how to manipulate it purely from images is a really hard problem and requires lots of processing and time and learning. So Mark Sullivan has devised this approach which vastly reduces the amount of visual processing required. So what happens is the appliance is fitted with an RFID tag, and the robot reads this RFID tag, which contains a 3D model of the object, together with metadata on how the object is used. So then once basically the robot has that object, on the bottom of the object there are 3 pressure points that triangulate its position. So the moment it's placed on that surface, the robot can read the RFID tag, get a 3D model. Using that triangulation, it can calculate the object's orientation. And from the RFID information, it knows then how to manipulate that object. And that really lightens the requirement for visual processing. So it's a very, very nice project. Okay, so robots are cool, but how about cars? So this is a Lancer Evo 2, and it's using a system called RaceCapture Pro by Autosports Labs. So RaceCapture Pro is a powerful, expandable, and customizable lap timer, data logger, telemetry system for your race car or street car. So what he's doing here is there's basically a hardware box that's connected to various devices around the car. You can measure air temperature, pressure, oil temperature, petrol. There's a whole lot of different meters you can do to monitor different parts of the car. They plug into that box, which also has a GPS connected to it, and a Bluetooth device. I think the second one on the left there is a Bluetooth device. That then communicates with your tablet running Kivy. Now, the nice thing is even the drivers can use their phones, their tablets. As long as they have Kivy running, they can just come and go as you will, which is nice because drivers can collect their own data, have their own devices doing this. So here we have his Nexus 7 running. Yeah, Nexus 7, and that, as I said, communicates over Bluetooth to the device and starts reading that data. You'll see here he's got a dashboard. He can go in here and basically configure what he wants to see on that dashboard. So that's the default setting. You can see his coolant display, the speed, the RPM, the oil pressure, but that's totally customizable. So each driver can come and remove the things they want to see, the data they want to see. They can also change the gauge limits when it turns red or green, but it's very customizable and extensible. We don't have time to go into really all the details of this app, but one of the things I'd like to mention is that this app makes use of the new SVG support introduced in Kivy 1.9. It's a really nice plus for us because we've been looking for a vector format so you can really scale up without having to have big bitmap resources. And anyway, so Brent Picasso was one of the developers, and he was experimenting with a way to increase the speed of gauge rendering. So these sensors typically have a sample rates in excess of 100 hertz, 1,000 hertz. And you can have sometimes 20 to 30 to 40 of these devices connected to a car. So that's a lot of samples per second you're getting. So it needed to respond quickly, and also he needed to have limits where he could set, I want this device to turn this color in this range, this color at another range, so you can get yellow warnings, red warnings, and each driver can configure what range the warning is and what color they see. So anyway, he discovered that SVGs have a current color property, which effectively determines the default color used when drawing an SVG. So he had a binding that when these limits were reached and the current color changed, this would trigger a repassing of the SVG. So effectively, just changing that node of the XML file in the SVG, that immediately updated the rendering. So you just update the node of the SVG, boom, your graphic is instantly re-rendered, and the response time on that is almost instantaneous. Another nice feature is that, of course, as a driver, you can't look at your tablet all the time, especially when you're racing. So there's a mechanism that this device, when it hits red, can send an alert to those lights you've just seen on the steering column. So the driver can set this thing to warn him, something he doesn't have to be looking at the device. It will flash on that unit right over there. So, and then in the thing after this, what happens is that that device also records all of this in a log file. So the driver can come later, and I'll show you just after this. There's a second program that accompanies which does analysis of that log. Let's just jump there. So yeah, this is the second part of the app. So you'll see here he's browsing, and he goes and selects that log file, which basically contains all the telemetry data for an entire racing session. So in this particular example, I think it's about sort of 6 or 7 laps that it's recorded. And the driver that can really, after that, go and do detailed analysis. For example, there you see his lap times on each of those laps it's recorded. He selects that lap, shows where he traveled, and now he can go and select which item of data he would like to see. And then along the bottom, you basically get that reading for that device according to the position in the track. And as you move the cursor over there, you'll see it updates the dot there, showing you where on the lap you were for each of those readings. So you can see where you were putting the clutch in, where you were braking, where you're accelerating. All of those points can be seen exactly. You can also, of course, go and add more of meters, so you can, and then compare them to one another. So this is a very powerful tool for racing drivers, and it uses Kivy, for basically all the processing and rendering. I'd love one for my car, but unfortunately it's probably a bit expensive. So here we see another Kivy app. This is called Flight Gear TQ Panel, and is an application by D-Laser that provides you with touch panel controllers for the open source Flight Gear aircraft simulator. Provides you with throttle controls, speed brakes, parking brakes, and more. A field of zoom, flaps, all of that from your mobile device. Apart from being ridiculously cool, it's one of those interesting things that the initial prototype was just 80 lines of KV code. So the way it's actually implemented is Flight Gear apparently supports the idea of generic protocols defined by XML files. So what you do is you define your own protocol, what ports, what commands you want to send and receive. You put that in an XML file, drop it into a specific location in Flight Gear, and when you next run it, it implements that protocol. So in this particular instance, it's talking over UDP to the flight simulator running on his PC. And you'll see all of these devices, this whole screen very accurately mimics an exact aircraft control panel. They've gone to the problem of actually seeing exactly how it was done and making a nice PNG that captures all of that data. So, Raspberry Pi, seeing as there's quite a few lying around. This is a small demo by Mark Richardson of Kivy using the official Raspberry Pi touchscreen. So you see here he makes it control and respond via a few LEDs. He's got a button there on a breadboard. He's got a little buzzer which you won't hear. He's got lights that flash. He's just plugged that into his Raspberry Pi via the GPIO input modules at the back. So GPIO stands for the General Purpose Input and Output Modules. And as you probably already know, there are a large range of devices that you can plug into a Pi this way. That means you can control and visualize all of these devices in your Pi using Kivy. You'll see there he's got buttons which you can switch on and off, and that slider, as you'll see, which will control the flashing of that light bulb. That button will basically toggle the button in Kivy on and off. The middle one will sound the buzzer, but you won't actually probably be able to hear that. And also represents stateful. So even on a hard Raspberry Pi, which is very modest hardware, it's still fully capable of running Kivy apps. Some of the sensors you can get for your Raspberry Pi: monitor air qualities, cameras, sensors, control quadcopters, drones, and of course robots. So you can do a lot of nice home automation projects. There really are just a lot of possibilities when you have such a flexible and low-cost option. So, while we are on the subject of controllers, we hinted earlier that Kivy is more than just a touch framework. And let me show you why that is. So next, we see the amazing Matthew Verbal demonstrating his ninja skills via the leap motion. So Matthew is also known to us lower mortals as Tito, and he's kind of the benevolent dictator for life of Kivy. He fathered Kivy and seems to produce amazing libraries as easy as most of us produce body odors. Yeah. So anyway, Kivy has full support for 3D input. You'll see as he moves his fingers, it picks up each of those individually. You can read the X, Y, Z input of those. That all works very nicely. It also supports the Kinect. Yeah. So here we have another project written by Matthew. This is the Kivy Inspector. So basically what happens is when you have a live running GUI, or whenever you launch if you want to, for example, enable the inspector, you just run your Kivy script with a -m inspector parameter, and it basically allows you to, at any time, just press Control-E or some keystroke, and then you get this inspector. Now, this also highlights the beauty of Python and its lovely introspective capabilities. Here, you can basically explore a live application in real time, looking at each widget, its properties. You can go up the parent hierarchy. You can go down into the children. But you can real time, and as you select, you'll see, that's that widget. And it's live. You can go and change these properties, edit your GUI while your application is live. Anytime you want it to go away, you can just close it, and it goes back to being a normal application. But the ability for this kind of live inspection of a GUI is very powerful. I mean, for example, if you have a problem placing a button, you can run it, open the inspector, go and see your button's properties. Try playing around with it, changing its center X value, its right value. All of these things you can easily do with this, the Kivy Inspector. So that's just one of the tools Kivy provides you with for debugging. There are also a handful of others. There is also a monitor module that allows you to add a top bar showing frames per second and input activity. There's a key binding module, so you can sort of catch keystrokes on certain operating systems. There's a recorder where you can play back and record a series of events, that's very nice. For example, if you want to do testing that involves touch interaction, you can actually do a set of recordings, use the recorder to record a session of input and play that back at another time, so you can automate even GUI testing. There's also a screen model for simulating various screen resolutions and DPI settings, because that varies quite wildly across devices. So it's nice to be able to test, for example, on quad HD displays, even on your desktop, because there are crazy high resolutions on some of those mobile devices, and you really run into some unexpected problems. Yeah. So those modules just really cover the debugging side. So, and there's no real time to go into all the other modules and classes that cover all aspects of the development cycle. But there really is a pretty complete tool set for that within Kivy. If Python provides a battery, Kivy provides a nuclear power plant, just without all the death and radiation and stuff. Okay, now after this we go into one of my favorites with Kivy, one of my favorite Kivy projects, because with Kivy, it's so easy to design a GUI, you quickly forget that you're actually working in a 3D space. So, because you never see OpenGL, you never have to care, so it's easy to forget. So this is a project called 3D GUI by Karol Piono-Charkabal, and it reminds us that Kivy is in a 3D world. Here we see a bunch of stock standard Kivy widgets running on a surface suspended in a 3D environment. These are all, you can actually, there's video widgets, there's an RST display which uses docutils underneath, there's video, there's sliders, there's buttons. All of these things work perfectly in this 3D space. What he's just done is provided us with another layout type. Kivy has a whole lot of layouts, box layouts, float layouts, grid layouts, all very useful. But this one handles a 3D layout. Because OpenGL also supports the loading of wavefront OBJ files, we can also load a 3D object and model into this Kivy scene and use that and interact with it just like any other object in our scene. So you can use Blender, Maya, Google SketchUp. Most 3D programs support exporting to OBJ files. So you can basically, using the 3D layout, load it in and interact with it. You'll see just now we're going to pop behind that surface, when he's done playing with the text box, which is actually wrapped around the bottom of that ball. You can see, and you can actually still use that text box. So here we go through. Here's a 3D model of a monument. There's our app currently running on the background. You'll see there's our text box widget. And you'll see just now he's going to start sliding widgets or the images over the house. I think you can see when there's a cat when you start doing it here. But yeah, so basically you can take your Kivy widgets, there you go, there's the image, move and touch them and move them fully interactive in a 3D world. For me, it's a very exciting proof of concept. Yeah, so I'm not sure I would actually use it, but the five-year-old inside of me wants to use it anyway. It's just fabulously cool. It's as if apps become toys in a sort of parallel cyber universe, and we can play with them. And by doing that, it really blurs the divide between apps and games. Anyway, this is the last slide, or second last one I want to show you. So we've seen Kivy on big screens, on huge devices. Here we see Gabriel Petier, also affectionately known to us minions as T-shirt Man, demonstrating a Kivy game of 2048 on his Galaxy Gear watch. So yes, the labels are too big. Yes, it's awkward to move the tiny tiles on a watch, but it's fluid, it's responsive, and it works. And it's a watch. So it's running a 1 gigahertz processor, 512 megs of RAM, running Android Wear, which is a lightweight Android distribution built specifically for wearables, but it runs Kivy easily. So that's pretty much it. But let's think. There's one last video I'm going to show you after I've finished talking. But let's just think about it. We've seen Kivy educating children, moving robots, helping the aged and mentally ill. We've flown aircraft simulators. We've held art exhibitions. We've raced cars. We've handled ninja chops in 3D. We've made lights twinkle on our Raspberry Pi. We've simulated particle physics. And we've swiped our widgets over 3D monuments. Now, if you don't think that's awesome, you're either dead or you're boring or you're both. So I'm going to shut up now and end my presentation with one of my favorite projects. I just hope I can get the sound going. I'm going to try and improv with sticking the mic down there, because there's a problem with that. But it's this project called, yes, you really need sound for this one. This is a project called the Touch Continuum. It's an instrument, it's a project called Icarus Touch, and it's a continuous keyboard written by Cyril Stoller of the band Liquid Rain. And I think it demonstrates the kind of creativity and beauty that Kivy enables. So before I go, I just want to offer up a massive, big, gooey lump of thanks to all the Kivy devs. Tito, T-shirt Man, Quanon, Ben Rouge, Kovac, Matam, Kived, Inclement, Desant, Tho, Picard. Thank you for all the awesomeness. Okay, let me just see.
We do have time for a couple of questions, if anyone has something they'd like to ask. What does it mean if it's flashing red and orange?
Can you run a WebKit window inside Kivy?
No, at the moment Kivy doesn't have a browser as such, a built-in browser. Like that. Is that better? Okay, so yes, it doesn't have an inbuilt browser as such. There is an experimental project called CEF Python, which is a garden widget. I think it only works in Ubuntu 64-bit at the moment. That is under development, but it doesn't have an embedded browser as such. Yeah.
So you could though connect to a REST API. It's got libraries for HTTP.
Yes, it's got all the Python URL libraries. It's also got its own URL request function for like doing async and having callback. But yeah, certainly it can act as a sending receiver. It just would be, it doesn't have an embedded web browser as such. So you can obviously on it shell out to the local web browser. There's a web browser module. You just go webbrowser.openurl, but then that will launch the browser app native to your OS.
I was looking for a shortcut. If you've got a web application, you just plunk your window there and you've got your...
You could look at CF Python, but it doesn't really make sense. Then you might as well use PhoneGap, which uses your native browser on the phone, because you're going to also lose a whole lot of advantages. It could be the fact that it's hardware accelerated, it's native, it's fast. Typically, if you are going to have a web app, you'd put it in PhoneGap and Cordova, do something like that rather.
I was meaning for like desktop applications. Which brings me to the next question. How easy is it to compile DMGs for Mac and EXEs for Windows?
That's a very good question. DMGs for Mac used to be a bit of a pain. iOS builds were a pain, but Tito just recently rebuilt the Kivy iOS toolchain and the Kivy Mac toolchain, and now it's very simple. Basically, you have a Python script build. It builds an Xcode project. You open Xcode, you run it, and it works. So all your dev work is done outside of Xcode. You still need Xcode to build anything for a Mac. But it creates the whole project for you. You work entirely in your normal Python side. You just use Xcode to open, compile, and test, but you don't actually do any code editing in there. So, but it's greatly simplified recently.
And executables for Windows?
Windows, that's pretty easy. It uses PyInstaller 2.1. It's very tried and tested. The only problem with Windows is because it's a full stack framework, it's quite a large EXE, unless you want to do a lot of trimming. But for example, with everything included by default with the docs, which is kind of the standard camera, it's about 120 meg install, which is big, because it includes GStreamer, it includes a whole bunch of stuff that it uses. You can bring that way down with PyInstaller. We just haven't gotten rounding to build it. We're mainly focusing on mobile at the moment. But it works perfectly well. It's pretty easy. And they've got exact sample of the PyInstaller script that you run to build your exe. And just to cravat to that, another very easy way if you want to get that up quickly and easily is the portable Python. The Kivy for Windows is a portable Python package which just runs a bat file. So you can just download that. It's all built for you. You just create another bat file which runs the Kivy environment, passing your script as a parameter. And you just reuse the Kivy portable package. And then it will just run on any Windows, self-contained.
Sorry, I'm having to run around with the mic.
You might have mentioned this, sorry if I missed it, but what is it doing under the hood is it cross-compiling between, say, to get an iOS executable and an Android executable? How does it actually do all of that?
Basically there's a Kivy for Android project, sister project, done by Kivy as well, and then on Android it uses Kivy for Android. There's also an equivalent one for iOS, Kivy for iOS, so it uses that, but they're their own Python into implementations basically, and then that runs within the Python build for that OS. So if that answers your question,
So it's actually creating a Python runtime and then executing.
Yes.
Okay. So each.
In the Python environment. So yes, and parts of the demanding parts are written in Python, especially on the OpenGL side, but your code can be is normally pure Python. The only complication you have there sometimes when you're distributing cross-platform, and it's not an entirely a Python package, you need a recipe in order to ship binaries that are appropriate for that OS. But Kivy uses a system called recipes for that. So for example, there's a recipe for LXML, there's a recipe I think for NumPy and SciPy now. So basically then Kivy just uses that recipe, and when you deploy it, it knows, okay, to install on this platform, I've got to use this binary downloads, and builds your package for you. So that dependency management is handled by the recipe for that. But most of the time, if it's pure Python, you can just put it along, pure Python module, you can just put it in your Kivy folder and then it'll work.
Oh, I think there was another hand up. Oh. No? Okay, if there are no more questions, let's thank Richard one more time. For Carl's benefit, this is the end of the talk.